Hello everybody and welcome back to day 12 of problem solving. Wait, what? 30 minutes of problem solving a day. Dude, we're almost done. We're going to do it for 12, 13, and 14, and then we're going to call it a series. And I'm going to premiere the last day of the series just so that if you guys have any feedback or you guys have any questions, you guys can ask me on the last day. Also, my voice still is a bit dead. I don't know why, but we're just going to go with it and see how it works, okay? I'm sorry I'm not going to be as energetic today, but we'll do our best, okay? So, we're going to start off where we left off last time, which is problem 9, and I've been way too long with problem 8, but it's okay. So, let's just get into it. Alright, Photoshop is there, and that is there, and let's do it. Okay, so find the number of ordered pairs m and n such that m and n are positive integers in the set, okay? And the greatest common divisor of 2 to the m plus 1 and 2 to the n minus 1 is not 1. So, there's a difference of 2 between them, right? So, like, what does that mean? Oh no, there isn't. No, I'm trolling. Bro, okay, so M and N could be different, so this is not like necessarily a difference of 2 or anything. Um, Basically, if their greatest common divisor is not 1, that means they both have to be divisible by some prime, right? And I guess, okay, well, they can't be divisible by 2, right? Because there's even plus an odd, so that's guaranteed to be odd. There's also guaranteed to be odd. So they can't be both divisible by 2. Very nice. So, they could either be both divisible by 3, they could be both divisible by 5, they could be both divisible by 7, or so on and so forth. And this looks a lot like Fermat's little theorem. Okay, so basically what Fermat's little theorem says is like a to the p is congruent to a mod p, which basically means that a to the p minus 1 is congruent to 1 mod p, right? So essentially, we want 2 to the n to be congruent to 1 mod p, right? And we want 2 to the m to be congruent to negative 1 mod p. Okay, so that seems like a good start. Okay, so basically we just need m that satisfy this. Why don't we just try listing some stuff out? What's 2 to the... Okay, so let's just list out power of the 2. 1, 2, 8, 16, 32, 64. Okay, maybe I should... I want to write the minus ones on top and the plus ones on the bottom, so maybe I should write it here. 1, 2, 4, 8, 16, 32, 64, 128, 286, 512, 1024. Okay, that seems enough. Technically, we could list all 30 and then we'd be happy, but I don't think we need to worry about that yet. So we got 0. No, wait, 1 is not even an option because m and n have to be at least 0, right? They're greater than 1. They're greater than 0. Okay, okay. So you can have 1, 3, 3, 5. Okay, well, here's one that works, right? Both of these are divisible by 3. That works. Basically, you want 1 from the bottom, which would be m, and 1 from the top, which would be n. Okay, so we got 7, 9, 15. So this works with these two, right? And this one works with these two, okay. We got, what is it, 17, okay. What else? Bruh, hold up. So then we got, yeah, 33, 31, that's what I was trying to do. Okay, 63, 65, 127, blah, blah. Okay, so we get the idea, right? Essentially, we could pair this with this. We could pair this with any thing that's divisible by 3 in the denominator, right? So essentially, what we find is that, like, basically, if this is negative 1 mod p, right? Then if you square it, then you get something that's positive 1 mod p, right? That's just how it works, right? If you square negative 1, you get positive 1. So essentially, if something over here is divisible by 3, if we square it, then the n minus 1 will also be divisible by 3, right? So, like, for example, if this is to the 1 plus 1, then we know that if we square this and subtract 1, we'll actually get something that's also divisible by 3, right? And then, like, same idea here, right? If we square this, and we got, like, 2q plus 1. If we square 2 to the 6 minus 1, that's 33, or sorry, 63, right? That's also divisible by 3. So, that works. Okay. Well, okay, we can basically see that, like, it's alternating, right? Every other one is divisible by 3, and the reason why this is because 2 to the 1 minus, or 2 to the 1 is congruent to negative 1 mod 3, right? And then 2 to the, what else? What else can we do? And then 2 squared is congruent to 1 mod 3, right? So then if we want a negative 1, we would just multiply 2 to the 1 times 2, time 2 to the 2 times 2 to the 1, because 1 times negative 1 gives you negative 1. So 2 to the 3 is congruent to negative 1 mod 3. So you can see this is why it alternates. So essentially, we could write this kind of table thing. Let's see, 3 What do we have? M and N. So M is 1, 2. Okay, so essentially any pair like this, 1, 3, 5, 7, dot, 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 2, 4, 6, 8, dot, 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 all the way to 30, all the way to 29. So if you pair any M on the left side, they're all going to be divisible by 3, and if you pair with any N on the right side, it's also going to be divisible by 3, so any pair from these two would work. So I guess that's like, how many here? 15 on this side, and 15 here, so any pair would work. 15 times 15. Okay. Now what about 5s? What about 5s? Let us see. So essentially, if you have like, okay, so this is the first thing that's divisible by 5, right? And then the next one is 15, right? So essentially, that basically means like you have 2 squared is congruent to negative 1 mod 5. 2 to the 4 is congruent to 1 mod 5, which means that like 2, 6, 10 is congruent to a negative 1 mod 5, and then the other side is just like, what? They're like 2 to the 4, right? So 4, 8, 12. Alright, so that's what we get. And this doesn't overlap at all with the 3, right? Because these are all even. And for the divisible by 3, it was all odds on the M side, right? So there's 2, 6, 10, 2 mod 4, right? So this goes to 30, right? And then this side, wait, no, what? Is that right? Yeah, that's right, okay. And then this side goes 4, 6, 8 to 28. So there's like 7 on this side and there's 8 on this side, so it'd be plus 8 times 7, okay. Now, we want to find, okay, what about 7 or something? Or any, okay, so this is 7, but there's really nothing that's negative 1 mod 7. Yeah, none of these are divisible by 7, so that's not possible. And we only had to look up to like 2 to the 7, and then it starts repeating, right? Because, well, once it's divisible by 1 mod 7, then it starts repeating, right? Because you go like 1, 2, 4, 1, and then it goes 1, 2, 4, 1, and so on and so forth. So once it gets to 1, you start repeating. So if there's no negative 1 before that, then you're never going to find a negative 1. And that means that you're never going to find an n that works. Okay, so 7 doesn't work. 11, what about that? Are any of you guys? Okay, so 33 is here. 11. And that's like 2 to the 5, so you get like 5 works. And then I guess the next 11 would just be you square it and minus 1. Uh, yeah, like you basically just do 2 to the, by Fermat's theorem, 2 to the 10. So you get like 5, 10, 15, 20, 25. These work. But this overlaps with all the 3s, right? We already had odds on the left side, even on the right side. So this is already, we already counted that, so don't worry about that. What else we got? 13. Okay. What do we got for 13? 13. Okay, so 65 works. So that's like 6, right? And then we have 12, and then 18. Uh, but this is like, so we have 2, 4, 2, 6. Yeah, okay, so this is just counted in the same thing as our 5. So this is counted when we counted 5s. Okay, so that doesn't help. 17 is next? Okay, 17. Anything divisible by, okay, so this is 17 right there. So that would be 2 to the 4, and then, so 4, 8, 4, 8, 12, 16, plus 8, 20, plus 8, 24, 20. Okay. So we didn't count this yet, right? Because we've only counted like 2, 6, like 2 mod 6 on the left side, but this has actually like 0 mod 4, 0 mod 4, not 2 mod 4. So this is a new thing, okay? So I guess we would just go, okay, so this is 4 times 3 plus 4 times 3, very nice. And then what about, what's next? We got 19? 19, what about 19? That gives you, what, 2 to the, like, is 2 to the, 2 to the, so what am I doing? 2 to the 9, so 2 to the 9 minus 1, so it should be this guy minus 1, 5, or plus 1, 5, 13, is that divisible by 19? Let's see. Divided by 19. Bro, dividing by big numbers is so triggering. Okay. 3, 1, 3, 7? 70 plus 60. Yeah, okay. So this works, okay. So 2 to the 9. So 9, 18. Okay, so this is like odd, even, odd, even. We already counted that with the 3, so don't worry about that. 23. Um, 23, so 2 to the 11 plus 1 should work, right? Because 2 to the 22 is congruent to 1 mod that. So, does this work? 2 to the 11 plus 1. That would be 20, 48, 49. 20, 49 divided by 23. Is that right? Okay, I'm assuming that's right. So you got like 6, 7, 8, 8. 8, yeah, okay. So that gives you like 160, 184, 29. Okay. Yeah, this doesn't work because this gives you like 207, so that's not right. Okay, so I guess 23 just doesn't work, right? Unfortunate. Okay. I mean, I don't think there's any negatives, right? Okay, I don't think that should work. Okay. What's left? 29. Okay, so 29 should be the last one we're thinking of, or maybe 31. We might have to look at 31. 31 would be would 31 work? So, well, okay, let's do 29 first. So 29 would be you got like wait, I feel like I'm missing something. Okay, well, let's look at over here whether we missed anything. So we already looked at all these guys. What's 129 divisible by? Let's see. 129 because 29 didn't work. That would be too big, right? You got like 14 and 19 or 14 and 18 or 14 and 28, which we already counted in our 5, so that doesn't even help. And 31 doesn't work either. So let's see. Divide by 3 or divide by 3, 4, 3. Okay. So 43. Okay, I guess 43 works because 129 is 1 mod 43. So essentially this guy is going to be like 2 to the 7, 7, 7, 14, 21. Okay, we already counted that, bruh. Oh god, this is nasty. We need to find another one. Or let's see if we can find another one and see if we can do it. Let's see. I guess we just have to go through these. So 257, what's that divisible by? Nothing nice? I don't know. Is it divisible by anything nice? 287. I'm pretty sure that's like a prime, right? Unless I'm trolling, but I'm pretty sure I'm not. Is it? Okay, whatever. It's divisible by some prime, right? That's not, that we didn't count yet. So that means that it's like, it's -1 mod some prime, okay? Which means that we could do 2 to the 8, 8, 16, 24. Did we count that yet? We did like 4, 8, 12 so far. Wait, so this still does work then, right? Because, yeah, we didn't count this one. Actually, no, this does fall. Oh, yeah, that doesn't fall. It's not the same thing. Okay, so this is a new one. Okay, so then we just do plus 2 times 1. Okay. Then we do 513. Is that divisible by anything? 513 divided by 3. 1217, 171. Oh, we should divide by 9. Oops. Okay, 171 over 3. Or that's also divisible by 9. So 1819. Okay, so that's 19. We already checked 19. That doesn't work. So that's not helpful. Are there any other prime data check? I don't know. Because this one's like really big primes, right? Which is why we had to check that too. 1024, 1025. I'm not sure whether we had to check anymore. How do you even check whether there's other things that work? Let's see. Is there any reason why it would be? What was there anything that's like one congruent to one mod something? Let's see. Oh, well, we only had to go to 15, right? So 1025, okay, I guess we could just go a little bit more. 1025, how much time have I spent on this one? I feel like we should just go with what we got, but 1025 is like, divided by 5 is, so basically multiply by 10, no, what? Divide by 10, multiply by 2. So you get like 205. Okay. Oh wait, you can divide by 25. Okay, so divide by 2 or multiply by 2, divide by 10 is 41. Okay. And that, did that help? 1025, so you could do like 2 to the 10. No, we already counted 10. We already counted 10, 20, 30. Okay. Okay, so I guess we already counted a lot of stuff though, right? We've counted, what do we count? We've counted odds on one side, even on the other. We've counted like, okay, let's just write out 1, 3, 5, 2, 4, 6. We have counted 2, 6, 10, dot, 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 and 4, 8, dot, dot, dot. Okay. We've counted, what was 17 again? It was 4, 4, 8, 12, right? And we've also counted, what was this guy? The last guy we counted was 8, 16, 24. So essentially we've counted like most stuff. Okay, so we could just skip over stuff. So could we do 11? 11 is definitely counted in here, so that doesn't count. We could do 12, that is counted in here, right? Because you could do 12, 24, but that's already here. Okay. We could do 13, that's already counted. 14, 14 is counted in here, so that doesn't even matter. 15, and 15 is already counted, so we've already gone through half of it. Nothing beyond that would even work, so we're actually done. Okay, so we really counted every single possibility. All right, let's go. So we got 225 plus 56 plus 12 plus 2. That gives you 281, 295. Is that right? Let's check. All right, let's go. Epic. All right, we know how to solve AIME number 9 still. I'm not that rusty, okay? My voice is rusty, but my brain is not quite. Okay, wait, let's go. It's a problem 10 Geo. I know everybody in the comments like to hate on Geo, but Geo is very epic, okay? Let's see how fast we can do this. So essentially we got 36, 36. You got like some sphere there, right? And then essentially we have like this, like that. And if we draw the other thing, it's something like that. And we have some planes. Okay, it's like that. Okay. All right. And now we want to basically find this distance right here. All right. Very epic. Okay. So essentially like whenever you have tangent stuff, I guess like let's see. What do we want to find? So we have like this stuff. We have this is like 36. This is 13, right? So essentially what we could find, we can find this height, right? And then we should, that's a pretty common right triangle thing. So once we have find this distance, we should be in good shape. Okay, well that's pretty easy using this diagram. So we have like 13, 36, 36, 36, 36, 13. And essentially this is just going to be 49 minus 36 squared gives you that. So you get 49 squared minus 36 squared. Difference of squared is very epic, so we don't have to do too much work. 13 times 49 plus 36. So that gives you root of 13 times 85. All right, let's go. So we got that height. Let's just say it's h or something, and we could actually write this out. So it's like this, and we want to find this distance over here, right? 13, 36 for h, okay. It might be actually easier. It might be easier if we find this one first, because we can do similar triangles. We can't really do similar triangles with this guy. So we get x over 13 is equal to x plus h over 36. This basically gives us 23x is equal to 13h, right? So essentially x is equal to 13 root 13 times 85 over 23, right? And then we just do Pythagorean theorem to get to this length, and we are done. So we could do like so 13 squared times 13 times 85 over 23, or actually no, we can literally even factor out a 13. So 13 and then root 13 times 85 over 23 squared minus 1. Okay. So what's 35? 13 times 85 is the question. So this gives you 5, 1, 2, 5. Okay. 0, 5, 8, 1, 1, 1, 0, 5. Okay. And then we got minus 23 squared, which is 529, unless I'm trolling. I think I memorized my squares properly, but I'm not sure. We'll see. We'll see if it's right. 6, what? Okay, no, what am I doing? It's like 0, 1, 9, 5. Subtracting is hard, I promise. Okay, 576, which is 24. If you take square root, so this is 24. Wait, what? What does 24 mean? Oh, over to like 23 squared, or 23 squared, and then there's like 13 times that. Okay, so what's 13 times 24? 13 times, wait, what? My brain is not malfunctioning. Okay, hold up. 2, 1, 7, 0, 4, 2, 3, 1, 2. So 312 over 529, and that gives us, that doesn't seem right. Is that right? That seems like a big number. Huh? Okay, yeah, okay, that's probably right. So essentially you get like 830 or 841. Okay, let's check it. I don't know if that's going to be right, but we'll see. 841. Oh, what? No, hold up. Hold up. So we got like 13 times 24, right? Um, wait, I'm pretty, okay, this is 20. Wait, what? So this is 24. Oh, over 23 squared? What? No, over 23. 13 times 24. Am I trolling? Am I really trolling that hard? Oh, it's 20, over 23. Why did I say over 529? Oh my god. It's literally, bruh, small brain. Okay, yeah. So 335, if that makes sense. Bruh, that was so stupid. Where did I even get the 23 squared? Holy. Okay, what time is that now? That didn't even take that long, so we could do 11. We could try 11. Okay, a teacher was leading a class of 4 perfectly logical students. That's impressive. The teacher chose a set of s of 4 integers and gave a different number s to each student. Okay. Um, then the teacher announced to the class that the numbers were 4 consecutive 2-digit positive integers. Okay. That some number was divisible by 6 and that a different number was divisible by 7. The teacher asked if any of the students could deduce what s is, but they all said no. Okay. Um, Oh, so once they knew it was no. Oh, that's a big brain. Okay. So essentially, you have two-digit positive integers. So based on what are they? Okay. So each student only got one one number, which basically means that none of the students could know if they like even if they got the divisible by 6 number, they would still not know what it is. Okay, what are some divisible by 6 numbers? Or divisible by 7, I guess, is less. So we got 7, or 2 digits. So we got 14, uh, 21, 28, 35, 42, 49, what else? 56, 63, 70, 77, 84, 91, 98. Okay. So, essentially, based on this information, they had one of these, right? One of them had one of these. Oh, and it was not divisible by 7? Well, it could be divisible by 7. Wait, no, there's only 4 consecutive, so it can't be divisible by 6. Otherwise, none of the other 4 consecutive ones would also be divisible by 6. So that's out. Um, could that work? 21, 24 is also, so that works. Which one? Okay, so which is divisible by 6? Uh, 42, 12, 84. So that's also out. Okay. So it's one of these. All right. And then I guess okay, let's write a multiple of 6. So 12, 2-digit positive. Okay, so 12, 18, 24, 30. Okay, we can't really have multiples of 7, so we'll just take that out. So 36, 42, skip, 48, 54, um, 60, 66, 72, 78, um, 84, no, 84 plus 6, 90, 96. Okay, so essentially one of them, okay, so if they have 96, then these are the two, right? Wait, so if none of them could deduce it, what does that even mean? Okay, so I guess, okay, so 96, 98. Let's see, why can't they deduce it if two of them have 96, 98? So essentially, if one guy gets like 95, if he gets 95, then he knows it has to be 95, 96, 97, 98, right? Because he can't get like 90, 91. Yeah, you can't have that other side. So in this case, like, if you got that, could you get like 96, 97, 96, 9? Yeah, okay, so that's also fine. So we basically need one where the guy who didn't get either of them can't figure it out, right? Because there's basically two options within that range. So, okay, so let's say you got 95, then the minimum, okay, so you get 92 or 90, 98, right? Yeah. So essentially, if there are two multiples of 6 and 7 within this range, like from this range of length 6, right? Then we are done. But how is that even possible? Oh. Okay, so we basically need in this range, the two ends are multiples of 6, and within there, there's a multiple of 7. And the midpoint is not the multiple of 7, is what I'm thinking. Well, actually, it could be. Okay. Yes, basically there needs to be two multiples of 6 with a multiple of 7 in between. So this doesn't have a, okay, this does have one. So why can't you do like 90, 93? Or so the four numbers are 90. So if you get 93, oh, well, okay, so if you get 93, that guy can't tell because it could either be 90, 91, 92, 93, or it could be 93, no, what? Or, wait, what? Huh. Okay, no, there have to be okay, well, let's see. Because in this case, there's only one option, so maybe, let's see, maybe between these, 78, 90. Okay, nothing in between 78 and 90, so that's not right. Wait, that's not even a distance. 6, okay. Uh, so you could do 72, 78 is distance 6. Does that work? Well, that doesn't work, because if you did it in the middle, only the one on the right would work, because 77 is too close to 78, okay. We could do 66, 72, that actually works. So if you did like 69, right, then essentially it could either be, wait, yeah, it could either be, no, that doesn't work. So that doesn't work either. Oh, so 63 is what it probably is, right? Because then you could get like, yeah, because then you could either have 60, 61, 62, 63, or you could have, or you could have 63, 64, 65, 66. Okay, so what about if okay, so let's just say it was 63, 64, 65, 66. So could the 64 guy know? Well, the 64 guy would know, right? Because the only one that's within, the only divisible by 6 and divisible by 7 ones in range of it are 65 and 66. No, so that doesn't work either. Uh, so the 4 could actually, I don't know. Well, okay, so each guy, basically, there's 4 options they had to consider, right? Either they have, like, their number, and then everything else is to the right of them, or their number is, like, second to last. Okay, so each guy basically has a range of 6, right? And all of their, and all of them have to have two ranges that actually work, right? So, for 64, that just doesn't work, right? So that's not good. What about, let's see. Um, But the problem is like you can't have two. You need it to be in like both ranges, right? You need that multiple of 7 to be in both ranges. Uh, okay, let's just try something else. So 54 to 60, you get 56. So the only range, if you go like that, yeah, you can't even get two multiples of 7. So you need two multiples of 6 in there, and then you need both of them to work. But then how does like other why don't they do like 60, 61, 62, 63? No, but this guy's only gonna have one, right? Oh, it was kind of hard actually. I mean, I feel like I know the strategy, right? But I don't know how to actually solve it. How much time is this? Hold up. Okay, well that's 30 minutes. We solved two problems. I'm happy with that. But we will continue where we left off next time, okay? Thank you guys for watching. So, remember, I will be premiering the last video of the series. I hope you guys enjoy it. If you guys have any other suggestions on what you guys want me to do, please let me know in the comments. But other than that, we are done for today. So, see you guys next time. Alright. Bye-bye.